morning. I'm Captain Moore, Martin County Fire Rescue's Training Bureau, training captain. Today we're going to be discussing some coefficients, particularly in relation to the key hose and national hose that we carry on our apparatus. One of the reasons we're doing this is that we'll be introducing a driver engineer task book out to our probationary firefighters very shortly. Within that task book, we've included a hydraulic calculation sheet, just so that we can get everyone on the same page. We're preemptively anticipating that we'll get some questions, particularly in relation to our coefficient to key hose. A lot of us know our key hose is supposed to be specifically designed for our 15/16 smoothbore tip. So we should have 200 feet of just key hose, and our national hose, we're keeping 200 feet for our fog nozzles on our crosslays. With that key hose, a lot of us know that FDNY spec, it's advertised as a 7 coefficient for the friction loss formula. That said, we've done multiple attempts now with various trucks. We've been doing our own calculations where we're getting technically about 12.8, so we'll be rounding that to 13, compared to the traditional 1 3/4 coefficient of 15. But that's a long ways from our 7, that's our advertised rate. So what we want to do is just talk about how we got to that number. We're anticipating some questions around that. So we're going to go through the process and really go through step by step, talking about what we're doing and how we're doing it. So we'll demonstrate that shortly, but just to talk about the equipment we're going to be using, we're using both an inline flow meter and an inline pressure gauge. Both on these lines, we're going to be doing a variety of different tests. We're going to be mixing the hoses, seeing what that looks like. We're going to be having just our key hose with our smoothbore, and we're going to be having just our fog nozzle as well. We're also going to be running just the crosslay with the additional pigtail. Then we're going to take that and just run it directly to the pump right off that fresh discharge. So we're playing with our various variables here, and we're going to try to keep getting or see what we're getting, anticipating if it's like our other test, we're going to get that 12.8 once we do the algebra with our calculation on that coefficient. So with that gauge, basically we'll be running, we'll be flowing. We have a Bluetooth connection. We can actually see the exact GPM that are flowing through that line. At the same time, we've got that pressure gauge right at the nozzle. Right, we're on our smoothbores, we want our 50 PSI, we'll get that exact. Ideally, we'll have that pressure gauge right at 50 when our flow meter's right at 100. So that's the main goal of today, that's kind of the goal of the video. That said too, we just want to put it out, training is slowly in the works of getting each individual apparatus its actual flow sheets as well. So we'll be using this equipment. If anyone wants to request it, just contact the training bureau so we all recognize that apparatus have their own little quirks, so we want to get specific rates for that. So that'll take us to the actual demonstration portion, which we'll move to here shortly. All right, so here we're at our key hose. As a reminder to everyone, with our key hose, we want that all to be on the same line, and that's on our smoothbore line. That's specifically designed hose. It's actually got a slightly larger diameter than our national hose, and it's designed for the 15/16 tip. So that's why we want that line to have that nozzle. With that said, you can identify your key hose. It says key hose right on the 50-foot section, and it's also got 2 parallel striped lines, a blue and a red line. Very easy to identify. So make sure that our trucks are actually properly lined up with that key hose and your smoothbore. That said, we're running here. We've got our inline pressure gauge. We're at 50 with the hand line, smoothbore tip. Back over here, we've got Captain Udinsky working with our flow meter. He's flowing at 185 gallons per minute now, which perfectly reflects our 50 PSI at the nozzle. That's what we want. Now our pump discharge pressure over there, right at the outlet, is right at 130 PSI. Okay, so this time we're running our national hose, right? So we've got our national connected with our fog nozzle. Our fog nozzle at 150 GPM. Got that set on our nozzle setting. We've got our PSI inline pressure gauge giving us our 75 PSI right at the nozzle. Then back here, again, we have Captain Udinsky with the flow meter, and he is right at 150 GPM, which is exactly what we're looking for. Our pump discharge pressure is 140 right at that discharge outlet. Okay, so here we've got our mixed hose. You can see we've got the inline pressure gauge working there with our 15/16 smoothbore nozzle. As we've said, we don't want mixed hose. That's just demonstration purposes. We want our fog nozzles to be with our national hose and our smooth bore with our key. If we come over here with Captain Udinsky, he's working on the flow meter with a Bluetooth setup. Fine tuning it. Right now he's at 186 GPM. We're hanging right around that 185, 186, 187 mark. Now at the pump, right where our discharge outlet is, we're at 150 PSI. So 150 PSI on the outlet with 185 GPM flowing, which is what we're looking for. Okay, so this was the next test that we did. We ran the same keys hose that we had last time, but what we did is we disconnected it from the pigtail, knowing we've got almost a 10-foot section here. So when we run our CQ squared L calculation to find that C, which was missing, we wanted a direct 200 feet. So we connected it right here. We did use a reducer. As a reminder, there's no friction loss if we're flowing under 350 gallons per minute with that reducer. So we've got a very solid reading here. Now when we did our math, we got a C value of 10.95. So I talked about my introduction on our other truck, we got 12.8. So this shows the importance of getting a specific reading to your truck, which again, training's more than welcome to assist, and we are working on that. But the big thing is here, right? I'm not saying this is how you guys got to hook up your cross laser or anything like that. This was just for us to demonstrate exactly how we got that hard Q number or C number, which in this case again was 10.95. That's still with our key hose, so it's a far cry from 7, which you'll see in our hydraulic formula reference chart. We've chosen the number 12, which kind of gives us that nice in between. Okay, so this concludes the demonstration we wanted to give to the streets. Just again explaining and justifying the steps we took to get the coefficients we got, specifically demonstrating why we've chosen that higher coefficient for the key hose. With that, we want to reiterate, with the key hose, that hose needs to be matched up with our smooth bores, right? The national needs to be matched up with the fog, so please make sure that your trucks actually reflect that. This demonstration has again just showed why it's so important to have your truck matched up with your hose. So don't hesitate to contact training. We'll come out here with the flow meter, with the inline pressure gauge, and we'll get your truck matched up specifically for what it needs to be. What we're presenting here is just a general recommendation. That said, don't hesitate to contact training with any questions or thoughts you have in relation to this video. Thank you for taking the time to watch it, and we look forward to seeing you on the streets.